Hi, my name is Omranali and today I'm going to talk about PAPR detection of OFDM. OFDM is a short for orthogonal frequency division multiplexing, and it is type of modulation technique that uses a large number of subcarrier instead of single carrier to transport the data. And it is used in many applications such as DSL internet access, wireless networks, and 4G and 5G mobile communication. It has many advantages such as high spectral efficiency, power efficiency, reluctance to frequency selective fading, and immunity to ISI and IFI. This diagram described OFDM system, where first binary phase shift keying coded the data in frequency domain. Then we apply IFFT to the signal to get the time domain of each frequency, which all will be added up and get transmitted. At the receiver side, FFT is applied to the time domain signal to get frequency domain signal, and then each subcarrier get decoded separately. Because of the large number of subcarriers that is modulated independently in the OFDM system, the peak value of the system can be higher than the average of the total system, which can lead to high PAPR. The picture below describes high peak after summing 4 different frequencies. PAPR reduction techniques. There's a lot of ways for reducing the PAPR, and these techniques are divided into 3 major categories. The first one is signal distortion, and the second is probabilities, and the last one is coding. Amplitude clipping. Amplitude clipping, it uses a clipper to reduce the amplitude peaks of the input signal to a fixed number. So if the signal exceeds the fixed value, it will get clipped off to the cutoff level as the picture below shown. This slide shows the block diagram of the PAPR reduction technique that I used and the Simulink model. The first 3 tool boxes are for generating the OFDM signal, and the red box is representing the clipping part, and for filtering the signal is sent to a MATLAB workspace to apply filtration. This slide shows the result of the simulation, where the picture in the left hand side shows the time domain of the OFDM signal, which is the original signal, and in the left hand side shows uh, the clipped signal. This slide shows the spectrum of the OFDM signal, which is the clipped and the original one. The picture on the right hand side shows the CCDF plot, where the PAPR value is 12.584 dB before clipping, and after clipping the PAPR value reduced to 6 dB. Now I will show you a demo of the PAPR technique, which simulated in MATLAB Simulink. So this shows the spectrum of the clipped and the original OFDM signal. And to get the CCDF, there is a built-in function in Simulink, which is right here. And this is the CCDF plot of clipped and original OFDM signal. And here we can get the measurement in the right hand side. This is the function I used for the clipping. And this function is just to get the normalized frequency. And this is the code. The first one is just to obtain the signal from Simulink and plot the original signal, the time domain, and the spectrum. This is the spectrum and the time domain. This one is for the clipping process. So this is the clipped signal and the spectrum of the clip signal. The last part is for filtering the uh, clip signal. So this plot shows the clipped signal, the time domain of the clipped signal and the filtered signal. Uh, I used a passband filter that I designed using the filter designer, and the magnitude response of the filter is this. And that's it.